Thank you all for joining us. In this session, we will talk about how to simplify modern application development when you're using one of the popular programming languages like Java, .NET, Python, and Node.js. I'm Santanu Datta, VP of Development, and I have with me Christian Shay, Senior Principal Product Manager. Here is the safe harbor statement, since I'll be talking about future product direction and they are subject to change. So our mission is to enable simple development and deployment of cloud-native mission-critical applications with converged Oracle database for all the different development communities. And we'll talk about how we are able to help you achieve that. So our agenda is first talk about development environments, how we support various development environments. And then we'll move into asynchronous and reactive programming model support, followed by our discussion on how we can help you make your application cloud native and mission critical, and then key takeaways. In terms of the development environments, we support all the popular programming languages. For C, C++, Java, and .NET, we have proprietary drivers. For Node.js, Python, PHP, and R, we have open source drivers, which are maintained by Oracle, but you can also contribute to them. For Perl, Ruby, Rust, and Go, we have open source drivers, which is developed and maintained by third parties. And we do work with them and help them whenever necessary. So we have the full spectrum of drivers to support all the development communities. Now, how do you get the drivers for use in your application? You can install them from all the standard popular channels like Maven for Java, NuGet for .NET, PyPy for Python, and NPM for Node.js. Our Java, .NET, and Python drivers are thin drivers, so you do not need to download anything else. Our Node.js driver currently has a dependency on Oracle Client, and you can download the Oracle Instant Client from oracle.com or through Oracle channel, Oracle Linux channel using dnf install command. So here are the different commands that you can use to integrate, download, and using our drivers from the various popular channels. Now, you surely need the Oracle database for doing the development. If you already have a corporate database, you can use that. But if you want a free version of the database, you can download it from oracle.com as Oracle Database Express Edition, or you can also get a cloud version of our free database, which is always free autonomous database. Now, as you talked about, we already have Java and .NET thin drivers for a long time. Now we have just released last year the Python thin driver. It is a major upgrade to our CX Oracle driver. And by default, it works in thin mode, which means there is no dependency on Oracle client libraries, which provides a greatly improved deployment experience and also support of many new platforms like Apple, M1, Alpine, and IoTs. It allows you to have a runtime choice to switch to thick mode if you are interested. It is distributed under the open source license available in GitHub, so that you can look at the source code and also contribute to it. We are releasing the binary module for performance reasons, and we are supporting the Python database API v2, which is a standard API, so that if you have developed an application for a different database, you can easily switch to use Oracle database. In addition to the Python thin driver, a Node.js thin driver is planned for release sometime this year. Apart from that, we also have some of the third-party developers working on thin drivers for Swift and Go. I wanted to share with you some of the driver downloads numbers. We are glad to see that our adoption is going up over the years. In 2022, we had around 116 plus million downloads for the 4 drivers combined. And 2023, we are seeing even higher adoption of the drivers. And surely you're excited by the growth of our drivers usage. Now we know that many of you use various frameworks and ORMs in addition to the database drivers. And that has been our latest focus to improve our integration with the popular frameworks and ORMs. For Java, we are working on contributing to Spring and Hibernate for improving our type mappings, particularly in the areas of JSON type and interval type. We have also released a Reactive Streams ingestion library, which allows you to have a very high-speed, highly performant ingestion into Oracle database, and which is shard aware. And we are also looking into integrating that with Spring. We have released Oracle RDBC driver, and we'll talk about it later. For the .NET, Entity Framework and Entity Framework Core are the most popular frameworks, and we have developed support of both the frameworks, and we have been supporting that for quite some time now. And we have recently released support of EF Core 7. For Python, SQL Alchemy is one of the popular frameworks, and SQL Alchemy 2.0 now has native support of our python-oracledb thin driver. And if you're using Pandas or Django, you can also surely use Oracle driver. And with Pandas, you can use the SQL Alchemy 2.0. In terms of SQLize, we have been working on contributing to SQLize, and our support of Oracle dialect has been now merged into the mainline SQLize code. So our focus is really to support all the different popular frameworks and ORMs with Oracle database. Now let us talk about database integration with popular IDEs. So we have been working on integrating with all the popular IDEs so that you can do end-to-end database development from within the IDE. For Oracle Developer Tools for VS Code is a plugin which plugs into the VS Code, and it is available from VS Code Marketplace. Oracle Developer Tools for Visual Studio is available in the Visual Studio Marketplace, and again, it allows you to do the development end-to-end within Visual Studio. A Database Navigator is a third-party product which supports Oracle Database, available in the IntelliJ Marketplace. And Database Tools is available in the Eclipse Marketplace. We also have Oracle Cloud Infrastructure Toolkit for IntelliJ and Eclipse, and both of them are currently available in GitHub, but we are working on making them available in the marketplace. As it is always better to see IDE in action, I'd like to have Christian demo application development using VS Code and Oracle Database. Over to you, Christian.
Thanks, Santanu. Now, in this demo, we're going to be cloning some code from a GitHub repository. Now, that code's going to include a Python web service app that uses the OracleDB Python driver. We'll be testing that Python code and running SQL using Visual Studio Code against the Oracle database, and then we'll push the code into GitHub, which will trigger a GitHub action that will build a container and push it into the Oracle Container Registry. Now, we won't show it in this demo, but then you could use that container in an Oracle Cloud service. Okay, this is Visual Studio Code. We're going to go to the Visual Studio Code Marketplace, type in Oracle, and install Oracle Developer Tools for VS Code extension. After we install, you'll see this database icon here and our Oracle Explorer. Now we'll need a database. It's easy to get an always free Oracle Autonomous database. Here in the Oracle Cloud Infrastructure Tree Control, you can click on this gear icon and it'll take you to a web page that'll show you how you can easily create an Oracle Cloud account. Once you've done that, you can follow the rest of the instructions to set up your configuration. It'll integrate here in Visual Studio Code. You can easily create your first autonomous database by right-clicking and selecting Create New. It will open up a Create Autonomous Database dialog, and you just need to provide your database name and the password that you want to use. And that's it. It will create it in a matter of minutes. Now, I already have one here called My Always Free, and you can see some of the options that are available to you for managing your autonomous database instance. Another option is to use Oracle Database Express Edition, the free edition, locally on your laptop. We're going to be doing this in the demo. You just click on the little gear icon here next to the Database Explorer, and it will take you to a web page that will show you how to get it installed. Once you've got the database installed, you can click the plus icon to open up the connection dialog. You can fill in the details, and the connection will be shown here in Oracle Database Explorer. Now, I've already got an instance installed here, but I don't have anything in it. So let's go ahead and go to my GitHub repo. Here's my GitHub repository with the files we're going to be cloning into VS Code for our demo. Let's go to VS Code again, and I'll press F1, choose Git Clone. I'll clone from GitHub and provide the repository name. I'll select the local folder I'll be pulling the files into. These files that we've cloned include a Python file, a Docker file, and a couple of SQL scripts. Let's take a look at one of the SQL scripts. This one generates the schema that we're going to be using and inserts some data into it. The nice thing is it's automatically associated with our extension and the connection that we've created. So all we need to do is select Execute All, and it will run the script. Now let's take a look at the stored function SQL script. You can see it's a couple of stored functions that return table data as JSON objects or a JSON array. Let's go ahead and run this. And we can take a look in the Database Explorer here and see that, yes, it has created tables as well as our stored functions. Now let's go ahead and open up a new SQL script and try some ad hoc SQL. We'll type select from employees and then go back and hit the space bar, and it will use IntelliSense to let us choose all columns. And then we'll click this format icon here, and you can see it's done a nice job formatting our SQL. You can hover over individual select list items to see the metadata for them. We'll hit Control E to execute the query. The data is in a nice grid control that lets you save in different formats. Now that same autocomplete in IntelliSense also works with stored procedures and functions. Let's make a call to one of our stored functions, get department by emp ID. Now you see when I hit enter, it provides a parameter list. I can type in the employee ID, say 100, add from dual, and execute it, and you can see the result is a JSON object executive. Okay, now let's take a look at the Python application. We're using Python for this demo, but you could have just as easily used any language such as Java, .NET, Node.js, etc. And this Python application is using Flask and exposing a couple of web services that are returning Oracle table data. We are calling those stored functions I showed you earlier. For data access, we're using the python-oracledb driver. You can see the import oracledb command here. And we're going to need to install the python-oracledb driver using this command here. So let me open up a terminal and run that command. You can see how fast it is to install this driver. Now, going back to the code, you can see that we have some environment variables called Python username, Python password, and Python connect string. And this is being used here when we create the connection pool. So where did those environment variables come from? Well, in Visual Studio Code, we put them in the launch.json. We already have my username and password here. We just need the connection string. So we can get that by going to my Oracle Explorer connection and viewing the connection dialog. I can copy the connect string and then go back to the launch.json and paste it in there. And now let me save my work. All right, now let's quickly run the app to see it in action. I'll say run without debugging, and you can see that it's listening here. We can click this suggested link, and you can see that it does return a JSON array of employees based on the department number of 90. We can change that to 100 and get a different set of values. Okay, now let's take advantage of the really cool Visual Studio Code debugger. We can go down here in the code and set a breakpoint or two on the web service. And then we can go to the Oracle Database Explorer and open up the stored function and set a breakpoint there as well. Now let's start the debugger. We'll say run, start debugging, and then we'll go to the web browser and kick off the web service. And you can see that the breakpoint is hit in the Python code. And now let's hit F10 to step into the PL SQL. There we are. We're in the PL SQL code, debugging it, and we can pop back out, right back into Python. That's very powerful. Now, as we mentioned at the beginning of this demo, we want to use GitHub Actions to build our application into a container and push it into the Oracle Container Registry. So I have a Docker file here, and you can see that it's using our Python app and building a container that runs it with Python. And then we have the YAML file here for the GitHub action. You can see that it's logging into the container registry using my secrets, and then it's building the Docker file and pushing it into my container registry. We'll go to the web browser and open up the Cloud Console, and you can see I do have this container registry here, and it was last updated 4 hours ago. So let's kick off the GitHub action by making a small modification to the code and pushing it into the repository. So I'll get rid of that comment, save my work, and I'll try to commit the change. I'll go ahead and provide the change log. And then I'll sync my changes. This will push it into GitHub. So let's go to the GitHub website and click on the Actions tab. And we can see that the publish action has started. And now it's completed. So that should have pushed the container up into the registry. Let's take a look. All right, I'm going to go ahead and refresh it. And there it is. It has been pushed into the registry.
Thank you, Christian. Let us now talk about asynchronous and reactive programming support. As application scalability becomes more and more important, we do see more and more interest in the asynchronous and reactive programming models. Since this allows your applications to scale better by releasing the application thread when we are doing database operations or some of the other functionality. So for asynchronous and reactive programming, you do see that the different languages are supporting different asynchronous models. And our goal is to support the language native asynchronous models for the different languages. For Java, JDK 19 has virtual thread support as a preview API. And you can use our JDBC 21C and higher with virtual threads support. And that will allow you to run your existing JDBC applications and get higher scalability. Then reactive stream support, we are seeing a lot of interest in reactive stream support, and we have introduced now reactive extensions to our JDBC to support Java Flow API. And we have also released an Oracle R2DBC driver, which supports R2DBC service provider interface. For .NET in 23C, we are supporting standard .NET Async Await APIs. For Python, our Async API is planned for release later this year. And for Node.js, we are asynchronous by default, but we are working on improving the performance by leveraging some of the network protocol enhancements that we are doing in database 23C. As we have been looking into asynchronous APIs, we felt that we could improve the performance even further by supporting pipelining between database client and server. Let us first see what happens when there is no pipelining. In those cases, basically the client and server, both of them spend a lot of time waiting for each other to send the messages. So the client blocks while it is waiting for responses for the server, and the server is also waiting for requests from the client. Now, what you are providing as a part of pipelining is that you can send multiple requests from client to server without waiting for responses. As you can see in this diagram, a client is able to send multiple requests to the server, and the server is able to process them one after another. As you can see from the diagram, you get a much better response time with pipelining compared to no pipelining. So what it results in is a highly improved response time and throughput with pipelining, particularly when the network latency is high, and you also get improved scalability. And what you can do is that if you're using any asynchronous APIs or reactive programming models or using any batch APIs, our driver will automatically try to leverage pipelining so that your applications either don't have to change or you have to just change it minimally to leverage pipelining. Now let us move into a little bit more details on what we support in terms of JDBC and asynchronous programming and the streams processing support. So if you're using JDBC thin driver and you're just using a JDBC blocking calls, then you are just using the JDBC calls using sync IO model. Now we have introduced a sync IO model in the thin driver, and on top of that, we have developed JDBC reactive extensions, which implements the publish subscribe flow interfaces. And using that, an application can use asynchronous streams with non-blocking back pressure. In addition, we have also implemented R2DBC, which is a service provider interface and implements the reactive stream standards. And using that, you can run various third-party reactive streams libraries like Spring, Reactor, Akka streams, or RX Java on top of R2DBC and the JDBC reactive extensions. And using that, applications can use all the power provided by the reactive streams libraries, including use of different operators and some of the concurrence modeling and tracing. And on the backend side, if you don't have pipelining, our driver will provide you database access without pipelining. But if pipelining is available, then the driver will automatically leverage database pipelining. So this allows you to leverage both the pipelining and asynchronous programming provided by Java. Let us see an example and a code sample of how to use JDBC reactive extensions. So let us suppose that you have two commands that you want to send to the server, insert and select. So using the async calls, you can create the flow publishers for both those calls. And then what will happen is that the driver can send them one after another without waiting for responses. And later on in the application, you come back and subscribe to them whenever you want to get the results. So again, you don't have to make any code changes to leverage pipelining. It is transparent. Let us to look at ODP.NET and how we leverage pipelining with ODP.NET. So let us suppose that we have a ODP.NET application which is using the standard ODP.NET and .NET Async IO await mechanisms. So you can create two tasks, and you can start both the tasks, and then later on you can wait for the task to complete. And then what the driver will do is that the driver can send both the commands, which can be insert commands, to the server without waiting for responses. if the pipelining is set to true, either as a deployment parameter or through a property. That again, we have made it sure that you can leverage pipelining with minimal or no code change. Let us now talk about cloud native and mission critical. The term cloud native is about building and running applications to take advantage of the elastic and distributed computing offered by the cloud. And the primary goal is to build and run applications that are highly scalable, available, secure, and observable. And these attributes also make your applications mission critical. Now, this is surely a complex subject because you have to look into all the different tiers and figure out how to make them cloud native. From the application component side of it, you can scale them using different cloud services and cloud technologies like containers, microservices, Kubernetes functions, and others. But as your application tier scale, you also need to look at your data tier and the database connectivity. And that can be even more challenging because of the persistence and transactional nature of your database connectivity. So in this session, we'll basically talk about your data tiers and database connectivity and how do you make sure that you can make the database connectivity and data tiers cloud native and mission critical. So we'll discuss 4 broad areas. First one being zero downtime for applications. So how do you achieve zero downtime during planned maintenance of the database and also when there are some unplanned outages of the database? Then we'll talk about application scalability, how we can optimize database resource usage while your application scales. Then we'll talk about unified observability and discuss specifically about diagnostics and open telemetry. And then we'll go into centralized configuration and the security integration in a multi-cloud environment. There are other sessions which talk about some of the server-side features like in-database microservices, Kubernetes operators, and some of the other features. But in this session, we'll be focusing more into the database driver and data access infrastructure side of it. So let us first talk about zero downtime. This is a part of Oracle's maximum availability architecture. So at a high level, on the server side, Oracle Database provides various technologies like real application clusters, active data guard, and others to make sure a database instance is always available, even when you are doing planned maintenance or one instance goes down. So this makes sure that the database client is able to connect to some surviving database instance all the time. And that is critical to make sure that you can achieve zero downtime during both the planned maintenance and unplanned outages. So let us go into a little bit more details under the planned maintenance. So during planned maintenance, whether it is RAC or active data guard, you will be doing a rolling upgrade and we'll be bringing maybe one instance down at a time. And as that instance is brought down, then from the server, it notifies the client that it is about to go down. And then the client pool will then drain the pool. What it means is that it will wait for the current request to complete and then do a disconnect from the server to make sure that there is no unfinished work within the current request. And once it is done, it will do a reconnect. And when it does a reconnect, it will go to another instance which is up and running. And using these mechanisms, the planned maintenance is completely hidden from the application, and the application can continue to run without being aware of any disruption on the server side. Let us now talk about zero downtime, how we can achieve it during unplanned outages. because things happen, and sometimes maybe the system is down, or the database is down, or the network is down. And as a result of that, the connection is interrupted. So what happens in that case is that the server side, the clustering software, will inform the driver pool that an instance has gone down. And sometimes, even if that is not possible, the driver pool will find it out through some network headers. And once it finds it out, it will then do a reconnect. And again, it will reconnect to a surviving instance of the database. But after that, since some in-flight work is in progress, what it does is that it will replay the in-flight requests, and it will guarantee correctness to ensure that no transaction is committed twice and all the work is completely consistent. So this is the technology which is called transparent application continuity. And this is a complex technology, but this is a very high-level overview of how it works. So what it achieves is that, again, you can achieve the complete transparency against unplanned outages without any code requirement to do any code change. Now let us talk about what is coming new in 23C. So far, transparent application continuity works pretty well for OLTP applications, but we see that there are a lot of batch applications and some of the other applications where the cursors are kept open for a very long time across a large number of transactions. To support those type of applications, we are enhancing TAC, and that will be available as a part of 23C. In addition, we are also adding the support of transparent application continuity in our ODP.NET managed and core drivers. And you are also doing some of the improvements in runtime and failover performance. Let us now talk about application scalability. Surely you should be using the driver level connection pool, and which has traditionally worked very well. All our drivers support connection pools, and that automatically grows and shrinks the pool based on the load. And the driver pools have built-in support of RAG, data guard, sharding, and other technologies, which also ensure transparent high availability and load balancing, in addition to node affinity matrix collection and other features. However, with the proliferation of microservices and the container technologies, we do see that hundreds or thousands of containers now coming in and trying to work with the database, and that result in explosion of database sessions. And then just use of driver level connection pool may not be enough, because the driver level connection pool can only pool resources and connections across all threads in a process, but it cannot pool connections across containers or across processes. To support these new types of application models, we have introduced now two other products and two other components. One of them is database resident connection pooling, which runs on the server, and it provides a server-side pool of dedicated processes called pool servers. And the application can basically change the connect string to use the pool server. And in that case, what happens is that the pool server is only allocated to the application when the application needs it. When the application does not need it, the pool server is used by other components and other applications. Though the driver pool thinks that the connection is still active and the network connection is still maintained. In addition, we are also supporting a proxy level connection pool, which is Oracle Connection Manager Traffic Director mode. And you can deploy it on the application side. For example, if you have a Kubernetes cluster and running hundreds of microservices, you can run cement TDM within the Kubernetes cluster, and all the microservices can talk to the cement TDM, and then the cement TDM can pull all the connections across the Kubernetes cluster and talk to the database server. And that way you have better utilization of the database resources and connections. Okay, let us now go into a some details on DRCP and cement TDM and very high level comparison between the two technologies. The most important thing to remember is that DRCP is integrated in database server, while cement TDM requires a different deployment in a different tier. Some of the other differences you can look up later on, and I don't have really time to go into more details on those. But one important thing we want to mention is that we are now going to support implicit connection pooling. So that even if your application is not using our client-side connection pool, or you are not using our pooling APIs to mark request boundaries, you can still use implicit connection pooling. And you can configure the pool boundary either at a statement or transaction level. So this surely provides you much more flexibility in terms of using DRCP and cement TDM. So in summary, we are offering you various technologies and deployment models for better scalability and optimizing database resources. Now, use of DRCP and cement TDM are surely optional, and you should only use them when your application requires them. Let us now talk about diagnosability. With the use of cloud, we do see more and more requirements to support non-stop operation of the application. And because of that, diagnosability also requires some rethinking. So you are looking at three major objectives or functionalities that you want to achieve through diagnosability. One is fast failure capture, secure logs and traces, and dynamic and selective tracing. Let us discuss that in the context of JDBC 23C, what we are doing. So for JDBC 23C, we have a single jar which is fully optimized, and we don't have to use any different jar for any of these different functionalities. And by default, fast failure capture is enabled so that you can find out any issues in the production environment without enabling any tracing. And then we also allow you to enable tracing, and by default, secure mode is enabled and your customer data is hidden. But if you want to look at all the packets, you can still do it, and which can be very useful for a development environment by setting some parameters. In addition, we are supporting dynamic and selective tracing so that you can enable and disable tracing dynamically at a statement level, session level, or a session pool level using either the APIs or embeds. And this will have very minimal performance impact because you are doing it extremely selectively. And all of that allows you to operate your application nonstop in a production environment, and still you are able to detect and diagnose problems quickly and easily. Well, let us now talk about OpenTelemetry. OpenTelemetry is the open source observability framework for instrumenting, generating, collecting, and exporting telemetry data, which enables end-to-end metrics, log, and tracing. And this is really critical for monitoring distributed systems like microservices. If you have a business request which goes through a very large number of microservices, it is very difficult to monitor and trace them. And that's where distributed tracing comes in. Distributed tracing records the paths taken by request as they propagate through various microservices. And the trace is made of one or more spans, and each component can create child spans to provide more in-depth context to the business request. So let us suppose you have an application running on a large number of microservices, and they are then also talking to Oracle database. Then what you can do is that from the application side, you can have all the traces, send it to the backend, and also the database can send the traces to the backend. And then the observability backend can then correlate all the different traces by using the parent and child span IDs and provide a unified view for monitoring and figuring out what's going on. And this allows you to look at bottlenecks and any issues that you have in processing business requests and resolve those issues. So this is an open framework, vendor neutral and multi-vendor. And this is being supported by the various vendors, including us. Now let us look specifically on what we are doing for JDBC and .NET drivers. For JDBC, as of today, you can monitor on all the top-level calls by using the OpenTelemetry Java agent. So what happens is that the Java agent creates a span for all the top-level JDBC calls. So you can monitor all the JDBC calls and also the SQL that is sent on the JDBC calls. So what we are doing in 23C is that we are providing callbacks in the drivers at the beginning and end of each round trip to create child spans in the context of the parent span. And this will allow you to enable monitoring of the database round trips and figure out what is going on, not just on the client side, but on the network side, on the server side. For the .NET side, we are integrating with the .NET OpenTelemetry NuGet packages, and an application can enable OpenTelemetry by constructing the trace provider and registering ODP.NET activity source. And the driver then uses Microsoft Systems Diagnostics to create the activities and the spans for all the database calls. So using all these enhancements in the drivers and also some of the database support we have, you can really have an end-to-end view of your business requests and unified observability. We'll now talk about cloud identity integration. In last year, we have released our integration with both Azure AD and OCI IAM. So if I have an application using OCI or Azure Identity Provider, then we are supporting a single sign-on to Oracle database, and that will allow you to do a passwordless access to Oracle database. So the application can then get the token from the cloud IDP and pass the token to Oracle database. Oracle database then can use the token and map it to database schema and roles. We are also supporting database link functionality by using the on behalf of token. So the database server can basically get an on behalf of token from the cloud IDP and send that token to the next Oracle database to support database link functionality. So using these functions, we are supporting centralized user management and centralized account policies in the cloud IDP for Oracle database, and also the single sign-on for users. Let us go into a little bit more details on the Azure AD OAuth2 integration and some of the enhancements that we are doing in DB23C. So as we talked about it before, we are supporting Azure AD authentication with Oracle database, both on-premises and cloud. So if you have an application running on Azure, it can get the OAuth2 token and pass it to Oracle database, and the database can validate and map it to the database user and role. We are currently collaborating with Microsoft to support Azure AD SSO of Power BI desktop and cloud service with Oracle database, and that should be coming in later this year. Now in 23C, we are making some improvements in our Azure AD authentication so that an existing applications without any code change can leverage the Azure AD OAuth2 integration. So far, an application could pass the tokens to our driver through APIs or through a token file. But in 23C, we are allowing an application to just specify the authentication mechanism through the connect string, and then the driver will get the token and refresh the token from Azure AD or OCI IAM and send it to the database. So this will surely allow your all existing applications without any code change to use the Azure AD or OCI IAM integration. So as I mentioned, along with Azure AD OAuth2, we are also supporting native OCI cloud authentication for Oracle Cloud Infrastructure. Let us now discuss the config providers for Azure. With the use of containers and microservices, as you have a very large number of containers or microservices distributed all over, it becomes more and more important to have a centralized configuration and secret management. So to support that, we are supporting storing connect string and other properties in Azure App Config Service and storing secrets in Azure Key Vault. And the client will go to Azure App Config Service to get the config object and go to Key Vault to get the vault object and use those to connect to the database. As an example, you can have a JDBC connect string as mentioned here. So you can say config Azure to indicate that you're using the config provider for Azure and you're using the object called config2. And within the object, you have a connect string called HR connection. And you can also use the level functionality in Azure App Config Service to store development or production versions of the connect string. And so these allow you to just, by using a connect string, to use the centralized configuration and secrets management on your application side. You don't have to make any code change. In addition to config provider for Azure, we also support config provider for Oracle Cloud Infrastructure, where we will be using the OCI object storage for storing the connect string and other properties in JSON document, and OCI Vault for storing secrets like passwords. To summarize, the key takeaways is that we are enabling simple development with Oracle database. You can continue to use your favorite programming language, framework, and IDE. Use the modern development paradigms and standard APIs. And you can easily and rapidly develop cloud-native and mission-critical applications with Oracle database. For more information, you can go to the link mentioned here for application development. And also you can post any questions you have in the forums. Here are some free resources that you have. You can try it for free. Thank you again for joining us. Hope that you will find some of the information useful.